So, I suggested you do this on page 5. I don't know how much room you have left. Page 5, it says extras on there. If you need more space, I think page 12 has another another entry there. So page 12 is a blank. So page 5, page 12. Okay. So I'm gonna go on to my study sheet, and I have a running study sheet here. I think I'm gonna try to fit the cone in here. Is that a good idea? Probably not a good idea. Just because you guys won't be able to read it if I do that. You can barely read it as is now. Me trying to squeeze that in. So let's just talk about the cone real quick. So a cone, let's make it upside down so that we're not always, it's basically a circle like that. It could be a paper cup, right? You know those paper cups that look like a cone, right? So we'll try to make this into a word problem soon. So the total surface area, TSA's total surface area, like all surfaces, would be pi r squared plus pi r s. And this is where, if you watch the video, which other shape has s? What does S stand for? Next period, Alice. What does S stand for? The slant height. Slanted, it's slanted. This is S right here. Okay, slanted, right? So when you're dealing with the surface area, you want the surfaces around it, you go pi r s. So this is basically the base, which is the circle, and this is the side. Okay, if you were to open this up, probably look like this, right? Like the side there. So keep that in mind. Actually, it should be pointed, sorry. Should be pointed. So you've got that. So therefore, lateral surface area, anybody remember what lateral surface area means? The sides only. So if you only wanted the sides, you don't care about the top, it would just be pi r s. No base, okay? Then we've got the volume. What's the definition of volume? Area of base times the height of the shape. Okay, area of the base. So what's the area of the base here? Pi r squared, right? And what is the height? Right? What is this? This is the height. So I'm actually going to go in here, and I'm going to make a diameter go right across. And then from that center point, I'm going to go straight to the top. Okay, that is the height. So don't mix up H and S. Okay, they are very different. But for a cone, you have to divide it by 3. Okay, or some textbooks, or if you look it up on Google, they'll have the 1/3. They'll take that on front, make it 1/3 pi r squared h. It doesn't matter. It's the same thing. Which shape has pi r squared h? Cylinder? So basically, think of a cylinder in thirds, right? You split it into thirds. And I don't have it on me right now, but a cool experiment is, if you take a cone and a cylinder with the exact same height and the exact same diameter, you're going to be able to take the water or the liquid that's in the cylinder and fill 3 cups. Right? Like the cone, if everything else is the same, the height and the diameter, you'll be able to fill 3 of them, because a cone is 1/3 of a cylinder. Okay, think of it that way. Okay. So this is the one I needed to, and again, Pythagorean theorem, if you forgot, right? I think you don't need this, Pythagorean. If you have this for the pyramids, you don't need this, okay? But basically, if you were to take out this right here, and then go straight down, this would be, within the context, would be the height of the cone. This would be the slant, okay, because the slant is on this side, it's on this side, it's like all around the slant height can be measured. And what is this? The radius, that's right, that's the radius. So if you want the slant height, that means that you would know the radius and the height. The slant height is simply square root of, this is the longest side, so it's the addition of the legs, and then square root that answer. If you want the height, if you want this, that means that you know the slant and the radius. So you'd go slant squared minus the radius squared, and just square root that, okay? So this is a little different than the pyramid, to be honest. So you may want to add this. One thing you need to be very careful is that sometimes students split the radius in half to put it in here. You only would split the radius in half if they gave you the diameter, right across. You would split that in half to just have the radius. So you need to use this to figure out one or the other. If I give you the slant, then you'll probably know the radius, and you want to find the height, use this one. If you want to know the slant, okay, and so remember, surface area only ever cares about the slant height because it goes along the face, whereas volume cares about the actual height, which is measured straight from at the center of the shape. Okay, keep that in mind. I think that's it for this one, this section. So